Okay, is everybody ready? Yeah. On your computers, ready to go? Okay. Okay, so again, so today what I'm gonna do is I'm gonna show you guys the process of preparing a 3D print specifically for this exercise. And because of the way that you guys like did your Boolean intersections, you'll see that, it's a little bit more complicated because we have to break down your 3D print into its components so that we can essentially take out each of the pieces along the vector. This will become clear in a second, but in which they get smaller in one direction. Does that make sense? So that we can like essentially take out your pieces of your mold out of your cast afterwards. Okay, so I'm going to do this again and we'll do this all together. But so I'm going to actually start out and I'm going to build a box, and I'm going to build it 2.5 by 2.5 by 2.5. Okay, so again, there's my box, and I'm going to do 3 intersections. So I'm going to do a cone, and a sphere, and a kind of another box. All right. So give me a second while I sort of place these randomly or, to in some fashion into this thing. Okay, so I have my objects here, and I think it's important in this case that we really are careful and make sure that you guys have your primary objects all complete and continuous, right? Like, so make sure, again, if you didn't copy paste it, make sure that you do or you find your original. Okay, so I'm just gonna now take that and just to see what it looks like, I'm going to copy paste it again. I'm going to do a Boolean difference. And I'm going to do, right, like the cube, and I want to subtract these things from it. So that's what I'm going to be that's what I'm going to be casting. This thing is going to be my cast. Does that make sense? Okay. So the thing about this cast is that you guys can see here, but essentially, if we start to try to think about how we would actually make this cast, we have a cone, this cone here, right? And we have a sphere, and we have a this sort of box-like object, right? So these are all along, we can think of them as being in or going along a vector, which in one direction, we can't take the object out of the box, and in the opposite direction, we can. But each of those objects have different vector lines, right? So to a certain extent, it's like the cone, we can take the cone out by generally moving it. I'm going to take ortho off, but generally moving it down and out, right? We can take the sphere by, because of the way that it's positioned, by moving it downwards, and we can take this rectangular piece by moving it along its vector line. Does that make sense? So what we want to do is we want to essentially 3D print those three as three separate pieces. So I think the first thing what we would want to do is, I'm going to again copy all of this just to have it here, and I'm going to again use my ortho so I keep it in line. And I'm going to do a Boolean split 3 times. So I'm going to do a Boolean split, and I'm going to split my sphere with the cube. Right, so I still have my solid cube, but now my sphere's split into 2 objects. Then I'm going to do another Boolean split, and I'm going to split my cone with the cube. Okay, and then I'm going to do it one more time, and I'm going to split now my boxed object with the cube. Okay, and now I'm going to copy paste again, just make sure you have always extras. And so now I can delete the pieces that are on the exterior extents. And I can delete that. Okay, so now we have the three pieces, right? And we can also imagine that those 3 pieces, we need to have them interlock into each other in a way that allows us to take them out from each other. So we have to use some of them to Boolean the others. Okay, so for example, I think the easiest one to think about is that probably we can Boolean this object out of this one. So again, I'm going to do another Boolean split, and I'm going to grab that, and then I'm going to split it with this object. So now this one is that piece plus its interior, this portion, right, which I can delete. Right, so now I have this piece and I have that piece, and they will essentially, I can move this out, but they will essentially slot into each other. Does that make sense? Yeah, absolutely. So we've so far up until this point, right, when we got to all of this stuff here, we had a bunch of Boolean splits. And now we're going to do some additional Boolean splits, but now the end goal is to split, and essentially create 3 interlocking puzzle pieces, right? And so we're just going to do it with Boolean splits. In this case, though, every one of you is going to have to do this in a kind of like strategic fashion. So I think in looking at this, the thing that is most clear to me is that somehow this box can slide vertically up and down from this larger volume. So what I did is I grabbed the larger sphere volume and I did a Boolean split of that one with the box. Enter. Right? And so the box still is, nothing's affected it yet. I haven't done anything to it, but this one is now those 2 pieces, this and the split portion. So I can delete the interior that overlaps with the box. And I mean, if I move the box out of the way, we see like, right, there is a slot where that piece would fit. Okay. So now we have a little bit more complicated issue, which we're gonna have to problem solve here together, which is this one, this piece here. But again, we can begin to imagine that this one would slot away from this volume. So again, I'm gonna grab this volume and I'm gonna do a Boolean split. And then I'm going to select this one as my cutting object and I press enter again. And again, now I can go in and delete this portion. So it's like, now I know I have this and it splits away from this. So again, I'm just going to quickly hide this. This is one of our 3D printed pieces. Right? And now we have these 2. And these 2, now we have to decide which one slots from the other. And I think the most logical thing is to say, I'll carve this one. I'll keep this one solid and I'll carve that little sort of corner out of my box. So again, now I would grab the box and I'm going to do a Boolean split. Subtract that piece from it. So I'm going to hide this, right? And I can now delete this extra piece here. And so you see we have this. Now if I go to show, you'll see I can hide this. And do you see how then now we have like the slot for that cone to come through? But we basically have 3 individual objects. Does that make sense? Yeah? That will slot together. I think because of the way that this thing, I ended up making this thing, I could essentially 3D print these separately, and then they will nestle into each other, and essentially with the, like maybe just a little bit of a, like one little glue tack or something, they would hold each other together. Like why wouldn't, they're not really going to be floating up in space. So this seems like a pretty stable 3-dimensional object. So maybe we don't need to do like add any pins, but I just want to show you what this idea of pins would be. So, in this setup, as we have it here, the way when we would cast this object, so I'm gonna copy now this object, and I'm gonna copy it to here so we can talk about this. But once what we're gonna do, right? I'm just gonna copy all this over one more time. What we're gonna do essentially is we're gonna take our 3D printed pieces, these 3, and we're going to take them and put them all together. And then we're going to build a little wooden box that surrounds them. So let me just show you, just so we're all on the same page here. Right, so we can imagine we have that box. I did a quick trick to get there. I'll show you guys that. I mean, it's not really relevant for this, but it was an offset surface. So we can imagine here that we're going to have like a wooden box that is larger than that is like, so that the interior volume is the exact size of our cast piece. And so we're basically going to do this, right? We're going to take that wooden box, we're going to put our little 3D printed objects in it, and then we're going to, on top, from the top, we're going to pour plaster, right? So when the plaster is all dry, right? When the plaster dries, it'll look like this, right? It'll look like a solid box. I'm going to copy it over just so everybody's on the same page again, right? How do we take it out? Yeah, exactly. So the box that we make, we have to make it, and we'll do that next week when we're in the shop next week. But the way to build this box is you build it out of pieces of MDF. But we can't glue the box together. We have to screw it together. And that way, once the box is ready, once the cast is ready, we unscrew it and we can take the box apart, like all the exterior of the box. Hold on, we'll get there. Yeah, so that's the first part, right? So then we'll have this. And so then procedurally, we have to think, okay, what pieces are we going to take off first? And so because of the way that we built this guy here, because of the way that we assembled this notches from both, and then this notches from this one, and this one slides last. The way that we're going to take it out is we're going to take out this cone first. And we're going to take out the cone essentially by moving it across the diagonal of its vector, like that, right? Does that make sense? So we're going to take this cone out by moving it along its vector, which, I mean, isn't exactly this, but it's essentially diagonally down, right? Because it's not, yeah, because it's getting smaller in that direction, right? Or there's more space behind it in that direction. And so we're going to take out that piece. And then the next thing we're going to do is we're going to then grab this piece and we're going to push it out, same thing, along its vector, kind of like this, right? So we're going to push that out. And finally, once that thing comes out, then we're going to take the sphere and we're going to take it out downwards. And then what's going to be left over is our object. Does that make sense? Yeah? Okay. So essentially, that's it. That's what we have to do. You guys just have to, we just have to make these 3D print these 3 separate objects. So, like I said, I was going to show you guys how to put little tabs into this, but I'm thinking maybe this is already complex enough and maybe we can just leave it like this. And if anything, we just use a little bit of hot glue or just anything to just help tack them together will be easier than trying to build little tabs. But essentially the idea of tabs would be like a quick version of it would be this. Would be that somewhere in between the intersection, we would build, let's say, a sphere, and we would Boolean that sphere out of one side and and attach it to the other piece. And therefore we'd have like a little like indent that helps us hold things. I think that's a little bit of overkill for what we're doing. Okay. So in order now to 3D print this stuff, I think this is important. You guys want to grab this. You'll need to copy it. And the thing about this is that we can't 3D print it like this all together, because then it'll actually be glued together. The print will glue itself together. So we're going to want to 3D print it and just move the pieces apart from each other. So you would submit essentially 3 individual pieces to get 3D printed. And like, for example, with this piece, something that I might do would be to rotate it 3-dimensionally across this axis to make it so that it's laying more flat. It'll probably be better for its constructability. But you can also just, if you don't want to, you can just, this is it. And maybe this will be good because then they're printed along, like if you think about a 3D printer, it's putting layers. There does. Yeah. I mean, this one does have a flat bottom, but yeah. Yeah. Ideally, you would do that. But if you're thinking about this, the one advantage of, for example, leaving these two in the same orientation is that when you 3D print, a 3D print puts layers or contours, right? And so if the contours are in the same direction, there's a higher likelihood that everything will sort of like match more precisely. Okay. So then that's it. So then once you have your 3 pieces, you would grab these. I'm going to go to units just to make sure that I am actually in inches. I am in inches. Okay. I'm going to hit OK here. And then I'm going to go to File, Export Selected. And we need to export it as an OBJ. Okay. So an OBJ, I'm going to call this, I'm going to go here to my desktop, call it 3D print or whatever you want. And then you're going to leave all this the same. You'll do OK. You can do more or less polygons. It won't really make too much of a difference. It's already going to be pretty good. And that's it. That would be the file that you would submit to the 3D printer. So again, to submit to the 3D printer, I'm going to stop sharing here for a second. And I'm going to share again, but share now. Go here, and we would go to OnePrat. Let it load for a second and go to production. And in the production, go to 3D printing. Like it says, it's open to all students, right? So we can all print from this, which is great. And then here, we have to let it load. Still a little slow here. Not sure why it's not showing the, here we go. Okay, so here in the submission form, we're going to select plastic because it's the cheapest one. We're going to select white PLA because it's the cheapest one. And then we'll go next. And then we're going to, again, do quick and low because it's going to be the least expensive. So quick and low means that it is both going to print it really fast and it's going to be low density. Low density means it uses less material. Therefore, because the interior of your objects aren't like fully solid, it uses a kind of a smaller thing. And then, do you want the 3D lab to remove your supports? I would say yes. There's a $5 charge. So, but you guys can do whatever you want. But you can, what you can also do potentially is like get your 3D models together and then like submit a model, like bundle them between 2 or 3 of you And the $5 charge is still just $5, but now it's like ends up being like $1.50.
So you can have multiple, like how many things always have one file?
So the maximum size of the bed is 7 inches by 7 inches. So you can place little, yeah, I think so. Okay. So you'll say either yes or no. You can also do it on your own. It's just gonna take you a little bit more time, but that's totally fine. And then you're gonna say, I verify that I have checked my file for errors and wall thicknesses using NetFab. And frankly, I'll show you guys if you want, but you just click yes, because it's the most obtuse program ever invented by man. And it's really hard. And I can look at your guys' models and I'll tell you. So don't worry about that, okay? And then the second part is I verify that my file has a flat surface at least 10 millimeters by 10 millimeters. And so you again will say yes. 10 millimeters is 1 centimeter. So like a quarter of an inch has to be flat on the ground. That's very easy. So I think everybody will be fine. And then you'll say your file is in inches, just because your guys' files are going to be in inches. And then you'll go to next. And then that's where it'll ask you, okay, great. Next. That's where you're going to go pick it up. And then it says upload your file. Okay. And that's when you upload your file. Your file, once you like Scott said, once you upload that file, it'll show up here. And they'll email you, they'll let you know the cost. And then you have to approve that, and then they print. And then they email you when it's ready. Okay. Does that make sense? So I'm going to stop sharing here. And I'm going to stop.